Hi class, in this recording we're going to be focusing on the cerebellum. The cerebellum means literally little cerebrum. There we go. So we have cereb for cerebrum, and then ellum means little, for the suffix ellum meaning little. So when we think of the cerebellum is going to be the largest part of the hindbrain and the second largest part of the brain overall as a whole. Why is that? Okay, apparently I can't put it up there in that corner. I'm going to put it over here. All right. Focus. That's not important. All right, here we go. Sorry about that. I got distracted. So as we're thinking of our cerebellum, it has left and right cerebellar hemispheres. We have left and right cerebellar hemispheres. And these left and right cerebellar hemispheres are going to, in many ways, have lots of the similar structures to the cerebrum as well. So we have sulci and gyri as part of the cerebellum. We have different lobes of the cerebellum. As we look at the cerebellum, it has a superficial cortex of gray matter with folds. This is just like the cerebrum. The folds within the cerebellum have been referred to as folia, and it also has a bunch of branching white matter within. So if we look over here at this mid-sagittal slice, you can see that we have a main stem right here of the white matter, and then it branches out to form a network that looks a lot like a tree. Hence the name of this structure, arbor vitae, which literally means, if we think of arbor, that's the Latin word for tree. Vitae is a root word referring to life. Arbor vitae literally means tree of life. It's also a kind of landscaping tree that's really, really hard to kill. And we're also going to have some deep nuclei. When we think of deep nuclei, remember, in central nervous system context, nuclei is gray matter. So we're going to have some regions of gray matter buried deep within the cerebellum. So one of the things that I find particularly interesting about the cerebellum is that it has the highest density of neurons in our bodies. It contains more than half of the neurons of our bodies, even though it's a small subset of the mass of the nervous system. So we have over 100 billion neurons present within our cerebellum. There are also going to be many small granule cells and large Purkinje cells. The granule cells and Purkinje cells are different kinds of neurons, specialty kinds of neurons. So here we can see a slice through a human, mid-sagittal slice through a human cadaver, cerebellum. Note that we have cerebellar peduncles. The cerebellar peduncles are 3 pairs of stalks that are going to connect the brain stem to the cerebellum. So we have the superior, the middle, and then the inferior cerebellar peduncles that help to connect the cerebellum to the brainstem. The inferior peduncles are connected to the medulla oblongata, the inferior part of the brainstem. The middle peduncles are connected to the pons, the middle part of the brainstem. And the superior, as you would have guessed, are going to be connected to the midbrain. So the top to bottom, superior to inferior, are going to connect to different parts of the brainstem, which we talked about in our previous lecture recording. As we look at the inferior peduncle, it's going to contain or going to relay spinal input centers to the cerebellum. The middle peduncle is going to take input from the rest of the brain centers through the middle peduncle. And then finally, the superior peduncle is going to carry cerebellar output. So in terms of the transmission, we are going to carry information into the cerebellum, to the inferior, the middle peduncle, and then the superior peduncle is going to carry information back up to the rest of the brain. As we're looking at the cerebellum is primarily going to be associated with motor coordination. That's why I made that the key word that I had omitted from the student copy of our notes. So when we think of the cerebellum, when you think of the cerebellum, I want you to think motor coordination. There are several other functions as well, and really when we think about the brain, there are lots and lots of functions associated with pretty much every part of the brain. But the big take-home I want you to associate with the cerebellum is motor coordination. We also have sensory processing, linguistic processing, emotional processing, and other non-motor functions, comparing textures, space perception. So people with cerebellar damage have a hard time working on pegboard puzzles. Different objects being recognized from different views. So rotating an object within your mind, judging time, maintaining tapping rhythm. For those of you who have ever tried to clap to the beat, this is something that's regulated by our cerebellum. Directing eye movements to compensate for head movements. So, for instance, people who are into ballet know that when a ballerina is spinning, the ballerina tries to keep their eyes focused on one position as long as possible. That way they can minimize the amount of dizziness they perceive. The pitch of tone, so high pitch, low pitch sounds, distinguishing between similar spoken words. So analyzing the tone of a word. You know, there's a difference between saying, I'm fine versus I'm fine. Having that different tone, that different inflection can have very different meanings associated with it. Having verbal association tasks are also going to be processed within the cerebellum, and then planning, scheduling, emotional control. Hyperactive children tend to have small cerebellums. And I'm laughing because I've been diagnosed with ADD. My wife's been diagnosed with ADD, and I guarantee my kids have ADD. They are just bonkers. Apparently, my kids and myself, apparently everyone in my family has a small cerebellum. Oh, I get a kick out of that. All right, that's all we have for our lecture recording. And we are going to go ahead and get this posted soon. If you have any questions, comments, concerns, please feel free to post them on the class discussion board, shoot me an email, or contact a friend. And as always, happy studies.